In today's lesson, we will talk about section 3.7, Angle-Side Theorems. To get into this first theorem, let's take a look at the given triangle. And given that line segment AB is congruent to line segment AC. Now, let's make a copy of triangle ABC and a mirror image. Again, AB still being congruent to AC. Since we know that it is exactly the same triangle, just a copy of it, we can say that line segment BC is congruent to line segment CB. We then can prove that triangle ABC is congruent to triangle ACB based on the side postulate. And once we know that all the sides are congruent and the triangles are congruent, we can then say that angle B will be congruent to angle C based on CPCTC. Corresponding parts of congruent triangles are congruent. Notice that the B is in this position and the C is in here. Again, when we talk about correlating triangles, the B corresponds with the C in this case. And since C is going to be the exact same over here, we know that B and C will be congruent in both triangles, and that will lead us to our first theorem. If two sides of a triangle are congruent, then the angle opposite the sides are also congruent. Knowing this, the converse is also true. If we know two angles of a triangle are congruent, then the opposite sides are also congruent. The negation or inverse of these are also true. If two sides of a triangle are not congruent, then the angles opposite them are not congruent. The longer side is then going to be opposite the longer side. And if two angles of a triangle are not congruent, then the sides opposite them are not congruent. We briefly talked about this in the last section, but let's go over it. Is an equilateral triangle the same as being equiangular triangle? And does equilateral mean equiangular? Let's look at the triangle now in the eyes of knowing our previous theorems. In an equilateral triangle, we know that all sides are going to be congruent. Based on the last theorem, if we know that a triangle has two congruent sides, the angles opposite them will also be congruent. Well, in this case, we don't know where the pair is. So it could be these two, again referring to the opposite angles. And using kind of the transitive property, all angles then are going to be congruent to each other. The next question, does equilateral mean equiangular? Take a look at a rhombus. A rhombus has four congruent sides, but you'll notice that the angles are not congruent. And then we have a rectangle, which has congruent angles, 90 degrees, but not all four sides will be congruent. So, in the first one, it would be always, and does equilateral mean equiangular? Would be sometimes. These proving the no cases, but a square, proving a yes case. Let's look at a proof from this section. If we're given the following, that line segment FG is congruent to line segment JH, and angle FGH is congruent to angle JHG, can we prove that triangle FKJ is isosceles? Let's start by marking our diagram. FG congruent to JH, angle FGH congruent to JHG. And let's think about what we need to do. We need to prove that this triangle is isosceles, meaning two congruent sides. And let's look at where FKJ is. We notice that FKJ is at the top center of the diagram. Notice that FK and KJ are a part of two smaller triangles, here and here, and it might be useful to prove those congruent. But based on the information that we don't have quite enough information for that. So let's think bigger. We can prove that FGH and triangle JGH will be congruent because we have a side and an angle. And if you notice, they overlap at GH, so we also have another side based on the reflexive property. By proving those two triangles congruent, it then gives us the opportunity to prove this angle right here, JGH, is congruent to this angle in here, FHG, based on corresponding parts of congruent triangles are congruent. Why is that helpful? Because we can take that angle and subtract it from the bigger angle, and that will give us these angles congruent, which are part of the smaller triangle we're looking for. Those bigger triangles also give us another corresponding angle that will help us. Angle GFH and angle GJH being congruent. This will allow us to say that the two smaller triangles are congruent based on angle-side angle. Now knowing that those two triangles are congruent, we can get to our conclusion. Notice that the triangle we're looking for overlaps those two triangles. We can now say that FK is congruent to JK, which will lead us to say that triangle FKJ is isosceles.